Hi, third graders. Today we are going to be talking about equivalent fractions. Before we talk about equivalent fractions, let's review some key things about fractions in general. So first, we know that we use fractions when shapes or number lines are divided into equal parts. That means that each part of the shape or number line or the whole in general, each part of the whole is the same size and takes up the same amount of space as the other parts. So let's review what I mean by that. On the left side, you see a circle that has been divided into 4 equal parts. So if we had a fraction problem, we could use that circle to help us out. On the next side, you see that there is a shape or a circle that is divided into 4 parts, but they're not equal. If all the parts aren't equal, then we can't use that for shape or for fractions. This is an example of a fraction. When you look at a fraction, you see 3 things. You see a number on top, you see a line in the middle, and you see a number on bottom. The number on top is called the numerator. The number on bottom is called the denominator. And these are 2 really important parts because they tell us something when we're working with fractions. The numerator, or the top number, tells us which part of the whole is shaded. The denominator tells us how many parts are in the whole in the first place. In other words, it tells us how many parts to split the whole shape or number line into. For example, we see that we have a circle that has been divided into 8 equal parts. If you look at the pink shaded part, one part of the whole has been shaded. So the fraction of the shaded part of the circle is 1/8 because one part out of 8 parts were shaded in. We also need to remember how to actually read fractions. When we read the numerator, we say it as we normally do. 1, 2, 3, 4, 5, 6, and so on. When we read the denominator, it gets a little bit different. So looking at the first example, 1/2. Well, we actually read that as 1 because we say the numerator the same, half. If the numerator was 2, you would still read it the same way, 2, because we say the numerator the same, halves. 1/3, 1/3, 1/4, 1/5, 1/6, 1/7, 1/8, 1/997. Okay? They have the same formula. We can also use a number line to help us with fractions. With a number line, the first thing we do is we look at it and we say, from this endpoint to the first point, that is 1 part, 2 parts, 3 parts. So this number line has been divided into 3 equal parts. That lets us know that any point on that number line is going to have a denominator of 3. Now when we actually go to label the numerator, we say, okay, this first point is part of or represents the first part of the number line. So the distance from 0 to this first point is 1/3 because it is 1/3 of the entire number line. The second right here, the second point, represents the second part of the number line. So the distance from 0 to the second point is 2/3. That's how we use fractions on number lines. Today, we are going to be working on equivalent fractions. Do you know what equivalent means? Let's see if you were right. Equivalent means equal. So now when we're looking at 2 sets of fractions, so 1 fraction, 2 fractions, we'll look at 2 fractions to determine, are they equal? Do they take up the same amount of space on 2 different shapes that are the same size? We're going to look at an example. We'll do a couple together, and then I'll have some for you to do on your own. When we look at these 2 squares, we see that actually they're the same size. The difference is that the two squares have been divided into a separate number of parts? Well, I know that how many parts the shape has been divided into also tells me my denominator. So first thing I'm going to do is find at least 1/2 of the fraction of each of these shapes. For this one right here, this first shape, this first square, well, I see that the square has been divided into 1, 2, 3, 4 equal parts. So automatically I know that my denominator is going to be 4 for this first shape. Well, then I move over here to my next square. Again, the same size as my first, but it's been divided separately. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. Oh, okay. So my denominator for this square is going to be 8. Now, to have a fraction, we have to have one or a couple of parts that are shaded in order to determine what part of the whole we're looking at. You see, in the first square, I do have a part shaded. In the second square, I don't. First, before we continue, can you tell me what fraction of the first square is shaded? If you said 1/4, you would be correct because the denominator, we know it's 4 because the shape was split into 4 equal parts. The numerator we know is 1 because only 1 out of those 4 parts were shaded in pink. The next thing I want to do is find the equivalent fraction to 1/4. And what I really mean by that is I'm going to find how many parts in the second square take up the same amount of space as my one part in my first square. I'm going to use the same, I kind of want to make the same shape as my first square. So let's look at this. My goal is just to fill in the same amount of space in my second square. Well, now I see, because my two squares are the same size, even if they were divided into separate parts or a different number of parts, that if I shade in 2 parts of my second square, it covers the same amount of space as this part over here on my first square. So the equivalent fraction to 1/4 here is 2/8. And that's because this square was split into 8 parts, but 2 out of those 8 parts, so 2/8 of the square, are equal to 1/4 of this square over here on the left. Let's look at another example. So now we have 2 circles. The first thing we can do is at least determine the denominator of our fractions. How do I do that? How do I determine the denominator? Good. I look at how many parts my shape, in this case a circle, has been split into. So in my shape on the left here, my circle, So in my circle on the left here, we see that the denominator is 2 because it has been split into or divided into 2 equal parts. What is the denominator of our circle on the right? Good, 4, because this has been split into 4 equal parts. Now, I can't find a fraction for this yet because I don't have a shaded region. I don't have a shaded part, so that's not really helping me out. Right now, it's just a hole. I can go to the left though, and I can say, okay, how many parts out of 2 parts, 2 of the whole, are shaded? 1. Good, so my fraction for my first circle is 1/2. My fraction for the shaded part of my first circle is 1/2. Now, I want to find an equivalent fraction, or a fraction that is equal to 1/2. Specifically, I want to find a fraction with a denominator of 4 that is equal to 1/2. So what I'm going to do is I'm going to shade in the same amount of space on my second circle and see how many parts I take up. Okay, so we see that now it's the same amount of space on this circle as the first. I'm just going to shade it in really quick. All right, how many parts did I have to shade to make it equal to this shape? 2. Good. So 1/2 is equal to 2/4. We can also find equivalent fractions by looking at a number line. If you don't remember how to find fractions by looking at a number line, first go back and watch my last video. In the second half, I explain how to do that. The first thing we need to do again is to decide for the first number line, what are those fractions going to be? What are my fractions going to be for these points on the number line? First, I can find my denominator. On a number line, we do that by counting the amount of spaces. Okay, so for example, to determine how many parts a number line is split into, we count the number of spaces. So from 0 to this first point right here, that space, that is the first part of this number line. Then from this point to the next, that space represents the second part of our number line. And then from that point to the end, it represents the third part of our number line. So we automatically know that this number line has been split into 3 equal parts. 1, 2, 3. We know that the denominator is automatically going to be 3. Again, because this number line is split into 3 equal parts. And we found how many parts it was split into by counting the amount of spaces on the number line. Okay? Just as a review, this first point represents the first part of the number line. First 1. So that point is going to be 1/3. This next point represents the second part of the number line. So this point on the number line is going to be 2/3. And that's because the distance from 0 to this first point is 1/3, because it's one part out of the 3 parts that the number line is split into. This point to the second point, 0 to the second point is 2/3 of the number line. And if we did the whole thing, it would be 3/3, which equals 1/2. Now, I want to determine an equivalent fraction to 2/3. Well, if I'm looking at my 2 number lines, I notice that the 2 number lines are actually the same size, and they both go from 0 to 1. The only difference is that they have been separated or divided into a different number of parts. Okay, but what I can do, if you notice, these lines on the first number line, starting here, line up to this line, this point on the second number line. And then I see over here, this does the same thing. So if I want to determine an equivalent fraction to 2/3, I need to decide, because these line up, which means these are equal, I need to decide what is this point on the number line. First, I do the same thing I did up here. I have to determine how many parts this number line has been split into. And how do I do that again? Good. I count the number of spaces. So from here to here. 1 part, 2 parts, 3 parts, and I'm just going line to line, as you can see. 4 parts, 5 parts, 6 parts. Okay, so this number line has been divided equally into 6 parts. So I know that each point on the number line at least is going to have a denominator of 6. But really, I'm only interested in this point right here because I need to determine what that is, because since these line up with the first number line, I know it's equivalent to 2/3. Because again, it's on the same part of the number line, even if they're divided differently. Okay, well, I know this point right here represents the first part. So it's going to be 1/6. Okay, well, I can kind of keep that going. This is the second part, so this is going to be 2/6. And then I see that these 2 points on the number lines matched up. So even though that wasn't my answer, 1/3 is equal to 2/6. Then we have 3/6 is next on the number line. 4/6, 5/6. So I know that the equivalent fraction to 2/3 is 4/6 because they line up on the number line. Now let's see if you can do one on the number line. I will give you the first one, and then I want you to determine what is an equivalent fraction to the point on the first number line. First, I have to determine the part that it's split into so I can know my denominator. 1, 2, cool. My denominator is going to be 2. I know that this point represents the first part, 1. So my point is 1/2. And you can see this because 0 to the point, it is 1/2 of the number line. It's half of it. I want you to determine what fraction is equivalent to 1/2 using the number line. Go ahead and pause and see if you can determine what fraction that is on the number line. It is going to be equivalent, right? If you determine that the equivalent fraction to 1/2 was 4/8, then you were correct. First, you had to determine that the number line was split into 8 different parts, separate parts. Equal parts is the word I'm looking for, which meant that the denominator on the points of the number line were automatically going to be 8. And then you just had to count. The first one represents the first part, 1/8, 2/8, 3/8, 4/8. When we look at 4/8, we see that it lines up perfectly with this 1/2. If I drew a line, it would connect perfectly. Since it is on the same space of 2 different number lines that are the same size, 1/2 and 4/8 are equivalent or equal. Guess what? There's another way where you can determine which fractions are equivalent or equal. And that is by using what I call, or what everyone calls, fraction strips. This is probably the easiest way to do it if you have fraction strips at home, but not everyone does. So we can see that these fraction strips all represent one whole. And we know that because if we look at this one right here, it says 1 whole. We're pretending this is a shape. Let's pretend this is a rectangle. This is 1 whole rectangle. It is not divided into any equal parts. It is a whole thing. So imagine if you got a pizza and it wasn't split into different pieces. That would be your 1 whole. You see that this 1 whole literally lines up, like it's the same length as every other fraction strip. And that's because when you put all of these together, so I'm just using tenths as an example, if you put them all together, it's going to be 1 whole. Now, if I said, I need to find a fraction that is equivalent to 1/2. First, I need to find where 1/2 is. Found it. Okay, so I've highlighted 1/2. Just that half of the strip obviously is 1/2. If we highlighted the whole thing, that would make it a whole. Because when you add 2 halves together, it makes a whole. I need to decide what fraction is equivalent to 1/2, but I can do that super, super easily. And I love this, that it's so easy. All I have to do, looking at where 1/2 ends over here, I'm going to draw a line straight down my page. And I'm going to see, where did it line up with the end of other fraction boxes perfectly? For example, let me draw that line again so you can see. Okay, I have 1/2. I'm going to go to the end of the box where it ends right here, because that's going to tell me the amount of space it's taking up. And I'm going to see which fractions does it line up with perfectly. Oh, it lines up with the end of this one perfectly. So I know 1/4, 2/4 is equal to 1/2. Okay, I'm going to keep going with my line and see what lines up. That's in the middle. Nope, nope. Oh, this is the end of a box. Okay, I need to add these together. 1/6, 2/6, 3/6. Okay, so I know that 2/4 is equal to 1/2 or equivalent to 1/2. I know that 3/6 is equal to 1/2. Guess what? It lines up again. 1, 2, 3, 4/8. And all you have to do when you're counting fractions on fraction strips is just count them. So I literally just count the amount of boxes. 1, 2, 3, 4. So that means it is 4/8. I'm going to keep going. Wow, it lines up with this too. It lines up with the end of that box perfectly. 1, 2, 3, 4, 5. 5/10 is equivalent to 1/2. And again, 1, 2, 3, 4, 5, 6. So 6/12 is equivalent to 1/2. There are so many options. Let's do one where you practice. I'm going to give you a fraction, and you are going to determine what other fractions are equivalent to that one. Okay, let's go with find an equivalent fraction to 2/3. And I do 1, 2. So I see which fraction does it line up with perfectly. So let's see if you can do that. If you can scroll down from the end right here, scroll down on this end and see if any of the other fractions line up or are equivalent. All right, so you should have gotten these 3 other fractions. So 2/3 is equivalent to 4/6, 6/9, and 8/12. And just in case, I want to go over again how to actually add up or count the fractions. When I'm looking at, let's use the 9th row, all I do is say 1/9, 2/9, 3/9, 4/9, 5/9, 6/9. My denominator stays the same, only my numerator goes up. All right, so let's do a quick recap. We know that equivalent means equal. So when we're looking for equivalent fractions, we're looking for fractions that are equal, even if they have a different numerator and denominator. We can do that in 3 different ways. One is by looking at shapes, looking at how the shapes are divided, and seeing if we shade in our shapes, what fractions take up the same amount of space. So 1/4 on this square right here, take up this triangle. 2/8 on this square, take up this same triangle. Okay, so 1/4 and 2/8 are equivalent fractions. We can also look at number lines. This looks a little bit messy, but we know that after we label our points or our fractions on the number line, we can look and see which fractions actually line up on our 2. On this, we found that 2/3 equals 4/6. It is equivalent, and that's because it is on the same place on two different number lines. We can also use fraction strips, and these are the easiest way, but not everyone has them. We look at a fraction, for example, 1/2, and then we determine which other fractions line up or take up the same amount of space, have the same length, okay? That means that those fractions are equivalent. So for example, in this case, we tried to find an equivalent fraction to 2/3. We found that 4/6, 6/9, and 8/12 are equivalent to 2/3. And now you know a few things about equivalent fractions.